Hi friends, now let's continue our discussion on PNP and all. It's a very commonly discussed matter in computer science, especially when we want to work at a higher level like compiler design, coming with machine learning, artificial intelligence, or maybe creating games and all that. Yes, we do deal with system which has got a very high complexity. So when dealing with a very high complexity, it always becomes difficult for making sure that whatever we have done is perfectly done or not. So there are many problems we can solve. So there are some set of problems which we can solve in a polynomial time. So that is if you are having n variables, so some order of n to the power k, where k is a constant. That is, it is independent of n. So there are many problems which can be solved in polynomial time. The examples would be adding two numbers, 2 plus 5. So that makes a constant time, or you can think of multiplying numbers 2 into 5. So that also almost takes a constant time. Then you can think of searching. So if you have n numbers to search, and if they are unsorted, then we require order of n, and the searching with n numbers, if they are sorted, we can go for binary search, and it's order of log n. Same way, to get the benefit of log n, we need to sort the array. So if there are n numbers in the array, and to sort them, so it may take order of n square, most of the algorithms, and some best possible algorithms may take n log n. So if you want to multiply matrix, so if you say matrix addition, then we have a matrix of n by n, so it's going to take order of n square. If you talk of matrix multiplication, then we are working with n by n matrices, so it's going to be order of n cube. So that way, so whatever it is, the common thing you can look at all this is some order of n to the power k, where k is 0 for this case, k is 1 for this case, and k is 2 for these cases, k is 3 for these cases, and so on. On the other side, there are some dangerous algorithms like 0-1 knapsack. So that takes 2 to the power n, and then we have traveling salesperson, so that takes 2 to the power n. Then we have a subset, sum of subset problem, so that also takes 2 to the power n. So these are the problems which are working in exponential time. Now the immediate question comes is how do they matter? Yes, of course, the question is very much valid. So let me just put that in simple terms, that let n be 100 and linear problem with 100 elements. Say if it takes 1 second, then the that is order of n. Then the order of n square will take around 3 hours to solve. And the same thing, if you talk about order of 2 to the power n, then it is going to take around 10 to the power 20 years. So I hope you understand the effect of this. So 100 elements are there, and if you just try to search from the 100 elements, if it can get you in maximum 1 second, then if you are working with a 100 by 100 matrices and you try to add them, then it's going to take up something like 3 hours of time. And if you are working on some 0 1 knapsack problem with 100 elements, then it would take almost 10 to the power 20 years to solve the problem. So I hope you understand the effect of these things. So we are not worried about smaller values of n. So nothing to do with the small values of n, but as the value of n increases very large. So why are we talking today about this? Is today is a era of big data. So when you're talking of big data, then there are billions of data available, and each data will have some hundreds of attributes. So hundreds of attributes of each data, such billions of data are there. So when you want to work on this type of problem, then definitely we would expect something like this. And if this is not possible, okay, at least this. And if this is not possible, okay, at least this, or whatever it is. So we are ready to compromise at most for some value of order of n to the power k, where k is a constant. So that means we are talking about order of some polynomial of n. So we are interested in order of polynomial n. So all the problems which are possible to solve in polynomial time are called P-class problems. So all these are called P-class problems, and these are exponential class problems. Yeah, so that's a thing to begin with. So we have many issues to look at. So as long as these P-class problems are there, we don't have any problem in working with this. But yes, we have problem in working with this type of problems, and it's going to take almost an infinite time to solve, and hence we need some way to work out and make sure to reduce this to a smaller value. And that's the whole aim of all the computer engineers, all the mathematicians. Since a century, they are working on this and trying to find solutions for this. And in this path, lot of research is done. So we need to look at what all things have done and how all can be improved, what all the various possibilities we have. Just we need to look at all of them and then look at what is possible, what is not possible, and if possible, how best we can do. If it is not possible, then what best we can go for so that it can become a little simpler than as it is. So many things to continue. So keep watching. Thank you.